All right, high school algebra, multiplying and dividing monomials. In last video, we talked about polynomials in general and combining like terms. So if you need to go back to that video, just go to part 1. Okay, let's talk about multiplying and dividing monomials. And for that, you need to know the law of exponents or the rules of exponents. Let's cover that. So let's start with multiplication, and let's get our pen ready. And we'll start with that color. So when we're doing, let's do multiplication first. Multiplication. So when we're multiplying exponents, so let's say we have 5 squared times 5 squared. Now when you're doing these, the law says that when they have the same base, keep the base. So we'll keep the base. It's going to be 5. And then add the exponents. It'll be 5 to the 4th power. So the first rule here, same base. Remember, the bigger number is the base, and the smaller one is the exponent. You know that, or the power. Same base means keep the base. Keep base. And add exponents. Or add powers, wherever you want to call them. So what would this be? 3 to the 3rd power times 3 to the 2nd power. What would that one be? They have the same base, right? 3. So you keep the 3, add the exponents. 3 to the 5th power. And what about this? 4 to the 3rd power times 4 to the negative 4th power. What do you think that would be? Well, again, keep the base, same base, add the exponents. 3 plus negative 4 is negative 1. So that would be the answer. And by the way, when you see a negative exponent, you make a fraction, make the base in the denominator, and bring the negative exponent down as a positive. And by the way, you don't need to leave that 1 there. It just could be 1/4. All right, so let's keep going. By the way, I'll talk more about negative exponents later on in this video. Let's clear this out. Rewind if you need to. So again, we'll talk about multiplication rules. So if they have the same base, keep the base. So let's say they have different bases. So let's say, and we'll keep that color, why not? 2 to the 3rd power times 3 to the 3rd power. Now, they have different bases, so you have to multiply the base. That'll be 6. But keep the power if it's the same. So again, if they have the same base, so here's the same base, keep the base, add the exponents. Different bases, but the same power, keep the power, multiply the exponents. Now, when they have different base and different power, there is no rule for this. There's no rule for this one. No rule. All right, so what would this one be? 7 to the 3rd power times 7 to the 3rd power. What would that one be? So they have the same base and the same power, but again, you keep the base, add the power. Always keep the base when it's the same. Don't do this. Don't do this. Don't do 7 to the 3rd power, because no, that's not that. You only keep the power when they have a different base and same power, like up here. All right, so let's use some variables now instead of constants. We've been using constants here. We'll use variables or indeterminates. Variables are also called indeterminates, like we talked about in the last video. So we'll clear this out, and let's change the pen. Why don't we use blue? If we can get blue, there it goes. What if I said x squared times x squared? Well, it's the same process. The base is the same, so keep the base, add the exponent. Simple as that, right? So what's this one? X to the 2nd times x to the 3rd. You got it, x to the 5th. Do a couple, you'll get it, right? What if we had y? It doesn't have to be x, right? What if it's y to the 3rd times y to the 7th? What would that one be? Y to the 10th. You're getting it. Excellent. Now, what if we had a constant and a variable? Like 3x to the 3rd times 2x to the fifth. What do you think this one would be? So you're only concerned with the exponents that have variables or constants with them, coefficients, right? So you just say 3 times 2 is 6. They don't have exponents, so just keep that as 6. So the rule is only when you have a base with an exponent. This base has no exponent. So 3 times 2 is 6, and then they have the same base, add the exponent. So try this one. What is 3x to the fourth times 4x? What do you think that one is? All right, again, 3 times 4 is 12. We just got to multiply those, multiply the constants. They don't have an exponent. And then the exponents, they have the same base, keeping the base. And the trick here is this will be to the fifth power. Why to the fifth? Because there is always a 1 when you don't see it. Don't make it 0. That's not 0. The only time it'll be 0 if you see a 0. So let's put a little line up here. Let's change it to green. So let's say, for example, I had 5x to the third times 2x to the 0. Now you see the 0. So this will be what? What do you think? 10, right? They have the same base, right? And you just add the exponents. Let's fix that 0. A little crooked. What if we had negative 5x to the fifth times 2x to the seventh? What would this one be? So it'll be negative. It'll be a negative 10. Just multiply. It'll be negative 10 now, right? Because negative 5 times 2 is negative 10. Same base, and you add the exponent. There we go. And what if we had multiple ones? So what's the one with multiple? What if I had 2x to the fifth times, let's say, 3x to the fourth times, let's say, 5x to the third? It's the same process. Just do one at a time, right? And again, with multiplication, you can do it any direction you want, right? You can do 5 times 3 first, or 3 times 2, or 2 times 5, right? You know the rules on that. So what do you think this would be? So 2 times 3 times 5. Do that first. Do the constants first. And you'll get 30, right? There's 30. They have the same base, so there we go. There's the same base. And just add the exponents. You'll get 12. All right. So let's clear this out. Let's do some more with some different variables. Let's say I had, let's say 4x squared and then a y times 7xy cubed. I think this one would be. So again, they have the same constants over here with no exponents attached, so we'll just multiply that, 28. So you're only concerned with the ones that have the same base. So x and x have the same base, so we'll make that x, add the exponents. Remember, there's a 1 there hiding. So it's a 3, not a 2. Remember, it's not a 0. They'll tell you if it's a 0. And what would the y be? What do you think the y would be? To the fourth, right? Exactly. Because there's a 1 on top of that y. Now again, let's talk about those negative exponents for a minute. Negative exponents. So again, let's say we had 5 to the negative third power. Whenever you see a negative, you make the base, you make it a fraction with the base in the denominator. So it'll be 1/5. Take the negative exponent and make it positive in the denominator. So you get that. So let's try this one. What would this one be? It would be 6 to the negative second power. What would that one be? Right. You make it a fraction with a base in the denominator and bring the 2 down. And you can go further if you need to with that. So now let's try dividing. Clear this out. Dividing, same rules with division, except you don't add, you subtract the exponent. So we'll put division up here, and we'll give you one. Let's say 18x to the 8th power divided by 2x to the 2nd power. So again, now it's division. Keep in mind, it's division. So we divide, right? That'll be 9. 18 divided by 2 is 9. And now we subtract right? So this will be same base, and we'll put a 6 there. So again, and sometimes you see it like this. Maybe we'll put another one. Let's say 18x to the 10th power. You could see it like that, right? Let's say 9x to the 3rd power. It's the same thing. So this, it's not the same question, but it's the same process, right? That's a division too. So this one, put this answer over here, it'll be 2, same base, and then subtract. So let's do some problems. Clear it out. So what if I had, let's change it to yellow. No, not yellow, red. Haven't used red yet. What if we had 144 x to the 3rd and 144 x to the 7th? See if you can do that problem. All right, if you want to pause the tape. So 144 divided by 144, you just got to have a 1. And you don't really have to put the 1 there, but we'll leave it there. They have the same base. And remember, it is division, so it's 3 minus 7. 3 minus 7. So you'll get -4. Now, how do you think you could... I mean, this is the answer, but we can also just say x to the -4th. And remember, when we have negative exponents, we put the base in the denominator and keep that 4 there. All right, let's do a few more of those negatives. All right. And make sure we have our pen. Let's stick with red. What if I had 12 x to the 5th power divided by 2 x to the -3rd power? That's an interesting one. What do you think this one would be? Be careful here. Okay, so 12 minus 2. Well, 12 divided by 2, right? So again, this is just like saying 12x to the 5th divided by 2x to the -3rd. So this will be 6, same base. But remember here now, be careful. It's 5 minus -3, which becomes 5 plus 3. Remember, keep change a long time ago? So this will be, what do you think this will be? It'll be x to the 8th power. Be careful when you see that minus there, because it's minusing. Keep that in mind. We'll do one more problem. By the way, just what the exponents. Remember, anything to the 0 power is 1, and anything to the 1st power is that same number or variable. Keep that in mind. Another thing to keep in mind is some students get this confused. X plus x is 2x, but x times x is x squared. And by the way, x times y is just x times y, right? Remember that also. All right, one more, right? Let's see, we'll use that. We'll use purple. What if I had 12x to the 5th power divided by, let's say, 6x to the oops, let's erase that. Let's clear that. Let's do this over. I didn't want to put an x. Let's say again, take 2, 12x to the 5th power divided by 6y to the -4th power. So now you can divide the constants. 12 divided by 6 is 2. But again, they have to be the same variables here. They're not. So we're just going to put x to the 5th and y to the -4. But remember what I said with exponents, negative exponents. So the y to the -4, it's a weird looking y, but would be actually 1y to the 4th power. 1y to the 4th power. But, very important here, the negative is already in the denominator. And I'm going to cover this in another video, but when you see a negative in the denominator, you can bring it up. So you would bring this up, this y up, and make it positive. So this answer would be 2x to the 5th, y to the 4th. So again, if you saw it here, just like this, you would make a fraction. But when it's already in the fraction, the denominator, you have to bring it up. Now, I'm going to explain that in other videos. But for now, that is our law of exponents. And we're going to cover now more combining like terms in the next video and multiplying and polynomials. All right.